To start with, I have to say that considering the restrictions and the regulations already presented, Mr. Efstratiu had the opportunity to tell us about everything, about registration, about restrictions and regulations. So it helped me to pass through a couple of my slides. And of course, Mr. Kokarakis said a lot of things on alternative solutions. So to start with, I have to say that given the technologies we have, in order to meet the restrictions and to fulfill all the needs, we have to violate physical rules. The first thermodynamic law, the second thermodynamic law. I believe that given the situation we have, it is impossible to meet the challenges. So we are forced, the academics, the researchers, we are forced to deal with new technologies. So we have a lot of damages, a lot of hazardous emissions. We have a rough estimation on the slide about the socio-economic cost of these hazardous emissions. So, what do we have to do? What do we need to do? There is a series of restrictions already shown in this room today, so I have to pass these slides and go directly to a potential solution, to methanol. So we have carried out a theoretical investigation using our software developed in the Hellenic Naval Academy, and we have also validated this software with the experimental work of colleagues around the world. So there are some things. We could call them advantages. Methanol is available. We have 70 million tons which are produced annually. The major source is natural gas, but we could also produce biomethanol from biomass. When we burn methanol, the combustion produces no SOx and very low NOx. Regarding the logistics and the infrastructure, minor modifications are required for storage, distribution, and bunkering. Methanol prices show regional variation. They are competitive in key shipping regions, and they are generally competitive during reduction of oil prices. Dual fuel engines using methanol and diesel oil perform lower specific fuel oil consumption compared to diesel-only operation. Methanol could also be used as hydrogen carrier for fuel cells applications. And finally, shipping and chemical industries have over 100 years experience in treating, in handling, in producing and treating and handling methanol. In addition, regarding CO2, methanol seems to be equivalent to LNG, but LNG is not the final solution. Mixing with biomethanol could lead to a significant reduction. Recent investigation suggests massive biomethanol production from waste, biomass, and CO2 plus water chemical reaction. But at the same time, methanol has also drawbacks. We hope there are countermeasures to avoid hazards, damages, and undesirable engine performance. We have to underline that for dual fuel use, there is no power reduction and no formaldehydes at the exhaust gases in case we use the methanol for dual fuel combustion. Actually, there are two approaches, two different injection and combustion concepts. The one comes from MAN. MAN design with main injection and pilot injection for the diesel. And the second approach is coming from Wärtsilä. We have a series of experiments that have been conducted to examine the engine behavior and compare different cases. 4 cases are examined: diesel fuel oil plus EGR, methanol diesel, and methanol diesel plus EGR. In these 2 diagrams, we can see the specific fuel consumption and the NOx emissions for these cases and for different loads. There is also another way to reduce CO2, NOx. You can reduce NOx increasing water content, and we can have blends of methanol with water to decrease the NOx emissions. Finally, I have to mention the second approach, the Wärtsilä approach, which was used for the Stena case, the Stena line vessel, where the Stena Germanica uses Wärtsilä sulfur engines consuming methanol as a dual fuel operation. And all the modifications used are shown on the slide. This is the solution, the modified engine for Stena Germanica. And to conclude, we have to summarize the pros and cons for the methanol case as an alternative maritime fuel. Having the green and red color on the slide, we can see that we have a chance. We have a chance using methanol, but at the same time, we have to solve a lot of practical problems in order for us to have a safe, a reliable, and a good solution. Not the final solution, just an alternative, just a solution as a bridge to a new technology, a revolutionary new technology leading to zero emissions or to carbon-free emissions or fossil-free emissions. Thank you for your attention.